All right, time for some further discussion from Chapter 1. We'll talk about atomic numbers next. Atomic numbers and mass numbers are things we use to describe atoms and make one atom distinct from the next. Atomic numbers are often given the symbol Z for reasons that you might not see right away. We'll look at it for a minute. And the mass number is given the symbol A. So what is the atomic number? It is the number of protons. And so that is a key thing we're going to want to know about every element. Those protons are in the atom's nucleus. A symbol for the proton, by the way, is sometimes just P with a plus sign to represent the charge. And it's always going to be equivalent to the number of electrons, that atomic number, as long as you have a neutral atom. For a neutral atom. We'll talk about atoms that are not neutral later. So for a neutral atom, the atomic number tells you the number of electrons also. The mass number, well, what's that? Well, the mass number is the things that have mass, they're the most mass, and that would be the protons and the neutrons that are the most mass in an atom. The electrons are very tiny by comparison, about a factor of 2,000 different about. And so the mass number is given the symbol A, and it is literally the sum of protons plus neutrons. So A is going to be protons plus neutrons. When we're described, you can find the mass number quite simply. Now, sometimes you'll look at different atoms, and they're going to be identical with atomic numbers, but different in mass numbers. And those atoms are described as isotopes. And we're going to look at examples of those kinds of things. So you can have more than one form of an atom, and you will call them isotopes. So hydrogen with a mass of 1, and hydrogen with a mass of 2, and hydrogen with a mass of 3 all occur. The symbols look like this. Hydrogen with a mass of 1 has that symbol. Hydrogen with a mass of 2 puts a 2 in front up there. And hydrogen with a mass of 3 looks like this. These are all the same element. They're still hydrogen, but they're all isotopes. Isotopes of hydrogen. Okay, so we'll look at some more examples. Now, atomic numbers and mass numbers. Which one is which? Well, the atomic number is the number of protons, right? And the mass number is the sum of protons plus neutrons. And so protons plus neutrons better be larger, right? Should be. And so apparently, the atomic number is shown at the bottom in these symbols for elements. And the number of protons or electrons, same thing as long as it's neutral. And the number above is called the mass number with the protons plus the neutrons. So one way of representing this idea of calling atomic number as Z and the mass number as A is using the symbol X for an element. The A is on top, the Z is on the bottom. The Z being the atomic number, and the mass number is on top, the sum of the mass of the protons plus the neutrons. Okay, so let's look at some more. Now, let me pause this for one moment. Okay, so different examples of different atoms. Nitrogen with a nitrogen 14 is the name of this. You can also call it N14. And otherwise, it's shown with this symbol here, nitrogen 14. If it's nitrogen, it's always going to have 7 protons. And so that's common to these two examples. And there's also a nitrogen 15. Nitrogen 14 has a mass number of 14 because it has a mass number derived from protons plus neutrons. And this number plus this number adds up to 14 in nitrogen 14. The atomic number is going to be 7 regardless if it's still nitrogen. Nitrogen 15 has a mass number of 15. And in this case, the protons plus the neutrons adds up to 15. So it has to have 8 neutrons instead of the 7 of nitrogen 14. Now, if you have nitrogen 14 and nitrogen 15, they're both nitrogen, and these are both described as isotopes of nitrogen. Same element, different masses, because they have different numbers of neutrons. That's what makes them different. Different numbers of neutrons. Neutron is N0, simple. All right, next slide. There we go. Without the writing in the way, there you go. Nitrogen 14 and nitrogen 15 are isotopes of nitrogen. They have the same atomic numbers and different mass numbers. That's how we define isotopes. Now, here's another diagram. What do we see here? We have little red and green spheres. The one on the left is called protium. There's a funny compound, funny entity. And it apparently has 1 proton and no neutrons. Mass number is going to be 1 because you have 1 proton and no neutrons, the mass number being 1. Here's deuterium. You have 1 proton and 1 neutron, and the mass number is 2. And that would be this entity here. And apparently you also have 1 electron when you have 1 proton. 1 electron here, 1 electron here, and the last one also has 1 electron because it equals the number of protons. It has 1 proton and 2 neutrons, so they have 3 different mass numbers. What are the same in each of these? Well, it looks to me like the little red sphere would be the protons. So the protons are the same in each of these, and it's 1. And so if you go to your friend the periodic table, which will be your good buddy by the time you get to the first test, when you see the number of protons is giving you the atomic number, the element must be hydrogen. Well, what's different is the number of neutrons. The number of neutrons is going to be 0, 1, or 2 in these examples, and that is how we get the 3 forms of hydrogen. The first one then is hydrogen 1, also known as protium. The second one is hydrogen 2, also known as deuterium. The third one has a name called tritium. Now, hydrogen's unusual that it has named forms, and these forms are all isotopes of hydrogen. And most other elements don't have named isotopes, but hydrogen is unique in that regard. So they're different because they have different numbers of neutrons, and that gives them different masses. All right, next slide. And just in case you needed a moment of humor, you say steam, water, and snow are all the same things. Frank and Ernest are having a conversation about chemistry. Yep, they're isotopes. Okay, grown when you must. We like cartoons that fit. So steam, water, and snow are all the same thing? Well, yeah, they're all water, but those are not isotopes. They're just a silly way of saying they're different phases of water in terms of gas, liquid, and solid. Okay, Frank and Ernest. That would be the end of this section. Time to move on to a new recording.